Hi, I'm Thomas Bowles, Prince William County Agricultural Extension Agent. Welcome to our video.
All right, it looks to be 11 o'clock, so we're going to go ahead and get started. Happy New Year, everybody. Welcome to the first of our Wednesday classes for 2022. My name's Thomas Bowles. I'm Agricultural Extension Agent here in Prince William County, and today's class is on soils for the gardener. Again, if you have questions, please put those in the chat box and we'll get to them at the end. So a quick history of Virginia Cooperative Extension. We're a partnership between state, county, and federal agencies. Our mission is to take research-based information and get it out to the public. And here in Prince William County, we offer programming in a variety of areas, including this one, environmental and natural resources. For those of you who pre-registered, there will be a class evaluation that will get sent out. If you didn't pre-register, please email us and request one. These help us be responsible and accountable to our funders, and it helps us get your ideas for new classes that we may offer in the future. So with that, we'll jump in. It's all about soils, and healthy soils make healthy plants. For more information on soils and soil health, you can visit these two websites. There is a For the Soil podcast that is about soils in Virginia. The new podcasts drop about every 2 weeks, and you can get those wherever you regularly get your podcasts from. So when we talk about gardening, understanding soil is key. It's all about biology. If we want soils to work for us, we have to ferment a good working biology in the soil. Our job is to protect and nurture that biology, and in turn, that biology will help our plants and take away a lot of our troubles, if you will. So what is soil? It's not just dirt, it's an ecosystem. It's a very complex community. There are inorganic parts like minerals, there are plant roots, there's organic matter, there's the microherd, which we refer to covering bacteria, algae, fungi, protozoa, and the not-so-microherd of insects, arthropods, and mollusks, and small mammals. And they all work together to achieve balance in a healthy ecosystem. They're going to maintain a balance between good and bad, and this will help with plant growth and reduce plant problems. Sometimes we talk about soilless media. Soilless media is sterile. It's designed for structure and not biology. It has some advantages. It's light. Because it's structure, it gives us good drainage. It gives us good room for roots. The bag mixes when we're talking soilless, we're basically talking about the bag mixes you get at the store. Lots of things can go into soilless material. Most commonly, we see peat moss, perlite, and vermiculite. There's a whole list of different things that can go into this. They have their advantages, especially for seed starting. They're also handy for containers because it's much lighter than conventional soil. And so as I say, seed starting, it's useful for, it's good for transplants. It's really good for hydroponics. It's good in raised beds, although you can argue that in raised beds, you can use native soil. Kind of depends on your native soil, but adding soilless media sometimes is your best option. And as I say, container garden, it's handy because it makes the pots light and you can move those pots with the sun fairly easily. One problem that we typically have with soilless media is hydrophobia, which means that sometimes it will actually reject water. And in this little demonstration, you can see that all the water has run down to the bottom of the pot and it's washed over this, it's gone down to the pot, and it will, because there is a cup underneath it, it will start soaking it in from the bottom up. So typically when we're talking about soilless media, we ideally want to water from the bottom. Soilless media may or may not have fertilizer in it. Because there's no biology, it needs some sort of fertilization. And like I said, it may be in there or you may need to add it. A lot of bag mixes now have slow release fertilizers in them, but not all of them. If your mix doesn't, then you want to add a slow release at planting and then maybe some quick release fertilizer like Miracle-Gro at critical growth stages. The sustainability of soilless media is kind of questionable. It really depends on what it's made out of. Peat is not very sustainable, but if we go back, rice hulls, ground pine bark, core, which is coconut husk, those are all very sustainable elements in soilless media. So what kind should you buy? It really depends. Potting soil or potting mix is kind of all purpose. It may or may not have fertilizer. There are some specialty potting mixes, have a structure that's suitable for specific types of plants. Like you can see here in the upper right, this is a SPOMO product that's designed, it has good drainage structure for cactus and succulents. If you're starting seeds, you want to look for a seed starting mix. Generally, it's the base material, whether it's peat or core or whatever, is ground finer. Usually it doesn't have fertilizer in it, and you usually don't need fertilizer in it because all of the nutrients that seedling needs is in that seed. When you transplant it, you would transplant it into a potting mix. There, you can design your own mix, get individual components, blend them to whatever works for you. Some of the more common recipes that we see are mixes of peat perlite and vermiculite. This is pretty much the one that a lot of our potting mixes are going to be. You can mix peat and sand. You can mix peat, bark, and different materials. What it comes down to is you want something that's got good structure, that's going to drain well, but still have enough moisture retention that you don't have to be watering your plants all the time. So let's talk about soil now and what makes good soil. Good soil has high organic matter, and that organic matter helps with the biological processing of nutrients. It helps with holding moisture. We want a soil that has good structure. It's got macro and micropores, and I'll show you examples of what I mean in a little bit. Good soil has good water infiltration. It's like a pond on the top. It's going to infiltrate deep into the soil, but it's also going to have significant plant available water. It's going to be a good habitat for microorganisms. It's going to allow for good root mass. Good soil has the appropriate pH, and sometimes we have to add lime to adjust that pH to get it to be a better soil. It should have low salinity. Salt is not a very conducive environment for most plants. It should be low in toxic elements. And it should have a balanced fertility. And what we mean by that is that fertilizer is not the source of fertility in natural systems. If you have a working ecosystem, you have that biology that's processing nutrients throughout the cycle, and your fertility is coming from that natural processing. And the common thread in this is that all of this is made possible by a living, biologically active soil. It's really all about the biology. If you get the biology right, so many other things will work out for you. So typically what we end up with, particularly in urban suburban areas, is really condensed, heavily compacted soil. Often it's a mix of weeds more than grass. There are minerals there, but they're not necessarily available. Generally, you've got less than 1% soil organic matter. There's very little sign of life in the soil. Most of the soil is going to shield water. It's going to run off. And it's going to favor anaerobic conditions, which favors the bad microorganisms that are going to cause problems for our plants and we don't want to see. I hear it all the time here in Northern Virginia. Oh, we've got red clay. It's bad. Clay is not bad. Clay is actually good for us. The problem is when clay gets compacted, there's no room for air or water or root growth. And so this is basically a brick that we're working with. And so we need to improve our soil in order to get a more conducive growing environment in our gardens. So what's the ideal composition? Ideally, we want half the space to be open, we'll say, with 30 to 20% of it being filled with air and 30 to 20% of it being filled with water. The solid portion is going to be mostly inorganic minerals, and then ideally about 5% organic matter. And this is much more like a sponge. It's open. And as we can see over in the lower right, we've got life going on in that soil. And that's really what we want to have, is we want to have our garden to be a complex, balanced ecosystem above and below ground. So how do we get there? Well, we start with a baseline. You need to know what you have to try and figure out, well, how do I fix this? And so you want to check your chemistry, your soil structure, and your soil biology. The easiest way to check your chemistry is to periodically test and amend the soil as needed. We recommend going through a reputable lab. Virginia Tech has a lab. We have soil test kits for about $10. In most states, you can get a decent chemical analysis of your soil. You want to use a lab rather than a soil kit because a lab is going to give you, it's going to figure out how much lime you need if you need to add lime. Whereas if you have some sort of tester like pH meter, it's not going to tell you how much lime you need to fix that pH. We recommend soil testing in heavier soils every 3 to 4 years. With sand, it's usually 1 to 2 years if you happen to be in the eastern side of Virginia. If you don't understand your soil test, whether it's from Virginia Tech, another university, or from a lab, call your local extension agent and have them go over it with you. Because sometimes, well, actually a lot of times, the reports can be a bit confusing if you don't know what you're looking at. So as I say, we recommend against home pH testing. There are a couple types. One is the chemical one, where you mix a little bit of water in with a little bit of soil, and it comes with a little capsule of chemical. You shake it up, you compare the color, and it gives you a rough estimate of what the pH is. And it runs about $9 to $10. You can get non-calibrating meters, which run $10 to $40, $50. Sometimes they're sold out of calibration. I used to be an ag teacher and used these a lot when teaching pH, and I would have to go every year. I'd have to set a solution. Usually I used Coke because I knew what the pH was, and we'd put the meters in just to make sure they were in calibration, and you'd be surprised how many brand new out-of-the-box meters were way out of calibration. So the problem with this is it may give you a little bit more accurate reading than the chemical type, but it also may be out of calibration. And again, in both cases you run into the issue of, okay, my pH is off, but how do I fix that? Whereas if you go through a lab, the lab's going to tell you, well, you need this much lime. And home tests, the chemical ones, high end, they're around $10. Meters, low end, they're around $10. For $10, you can get a university test. So it makes more sense. And also the lab tests are going to give you more than pH. They're going to give you minerals. They're going to give you nutrients. You can check your soil structure. Again, I get a lot of, I've got clay, and a lot of times it's not really clay that they have. They have clay loam or silty clay. And you can test that by doing a ribbon test. And a ribbon test is basically you get a ball of soil, you dampen it, roll it into a ball, and then you use your thumb and forefinger and try and get a ribbon out of it. Depending on how long that ribbon is, it will tell you what type of soil structure you have. The other way to do it is a jar test. In a jar test, basically, you take a jar, you fill it with soil, you add a little bit of water, you add a drop or two of dish soap, you shake it up, set it aside, and you let it settle out. And so in this picture here on the left, it's still settling out, but you can see that the layers are developing. And then you go and you determine, okay, this percent is sand, this percent is silt, this percent is clay, and then you use a soil triangle to figure out exactly what your texture is. Another way to check your soil is to look at it regularly. A lot of times we take our soil for granted and we don't actually look at what's going on. In this particular picture, we can see a number of things going on. This over here, this white, this is mycorrhizal fungi hyphae, which is a good indicator because these work with roots actually to extend the reach of roots. We've got pretty good root mass there. And we have our friend, the worm. So when you're checking structure and biology, there are a lot of things you can do yourself. And in New South Wales, which is a state in Australia, they developed a soil health protocol that you can easily do and you can do on a regular basis to get an idea of, okay, I've done this to my garden. Is it helping or is it hurting? And one of the things that you want to look at is how easily can you penetrate the soil to 8 inches? And usually what I do is I get a rod, and I thought I had it with me, but I didn't bring it today. But I mark out with inches, and I just stick it in and see how far it goes without a whole lot of pressure. You want to see how easy water infiltrates. Is what you're doing making the soil more compact and shedding water, or is it making it less compact and allowing for more infiltration? When you look at your soil, how many species can you find? Are there a lot of fine roots in the root zone? Is the soil friable? And what that means is when you kind of put it between your fingers, how easily does it break into about marble-sized crumbs? When you drop a soil aggregate or a piece of soil in water and swirl it around, does it remain intact or does it break up? If it breaks up, there's not a whole lot of organic matter there. If it stays together, that means that there's a lot of biological glue holding that together and holding that structure. And are you getting the appropriate vegetative coverage? And I have these, and if you email us, I can send you copies of these. As I said, this is based on the New South Wales protocol, and it gives you a way to rate your soil. And it covers the things I just talked about. Whoops, these things. Looking at ground cover, compaction, diversity of soil life. What do the plants look like? What do the roots look like? What's your soil structure like? How stable are the aggregates or the pieces of soil? How many earthworms are you seeing? And this is a handy thing to do periodically. And with all soil testing, whether it's chemical or physical or this type of biological sort of soil health look, you want to do them at the same time, about the same time of year, every time you check them. That will eliminate some seasonal variations. Also, I wouldn't recommend looking for biology in the wintertime because typically our earthworms and other creatures are a lot farther down because they're not active because of the cold. So as I mentioned, you want to check it basically about the same time of year, check your chemistry every 3 to 4 years, and check your structure and biology annually. Some resources, if you need a soil test kit, email us. We'll be happy to send it to you. If you're out of state, most but not all states have soil tests through their land-grant universities, like Penn State, for example. Or they can recommend you to a reputable lab. If you're in DC or Maryland, email us. We'll send you a kit. You can still send it into the Virginia lab. It'll work. If you're in West Virginia, I think West Virginia still has their lab. NC State still has their lab. In both cases, you could get it done through tech, but you have your own lab, so I'm not sure the cost difference. There are also more information on ribbon testing and other soil information on the Natural Resources Conservation Service website, which is part of USDA, and more information on the soil health check at this at this website. The version that I have, I've changed everything into English measurements. The soil health test card that Australia developed is in metric, and that's the big difference between the two. So let's talk soil building. Let's take our brick and let's turn it into a sponge. Let's make it better. And we want to do that by reducing the disturbance of the soil. We don't want to disturb it chemically or physically. So we don't want to do a whole lot of tilling. Tilling is sometimes necessary, but we want to reduce tillage. We want to reduce chemical applications. We want to mix our plant species. And we want to do that because if you think about a natural system, a natural ecosystem, you don't have, for example, a forest of just white oaks. You've got a mix of plants. If you look at the prairie, you've got a mix of grasses and forbs. It's not one species. And by mixing plant species, we get different microorganisms in the soil that are active, and that diversity helps keep the system in check. We also want to keep the soil covered as much as possible, and we want to maximize the living roots in the soil, which means we want to have something growing throughout the entire year if possible. So I mentioned aggregates. If you blow up a BB-size aggregate or piece of soil from a soil that's been organically managed, uses cover crops, all the soil health principles, you're going to see something that looks like this. And the blue spaces are places where you've got pores that can hold water, can hold oxygen, can be a life or can be a habitat for certain microorganisms. Where you've got green, this is organic matter, which is food for those microorganisms. And this type of structure helps hold the soil against compaction. Because part of the process is these microorganisms, part of their waste product, they exude these glues. And these glues allow these aggregates to glue on top of each other and to hold in place and resist compaction. If you have a soil that's heavily worked, that's tilled a lot, that's worked when it's wet and compacted, you end up with very little pore space. Without these biological glues, they break apart very easily, whether it's physical pressure or whether it's, erosion or pressure from water and they erode. And so when you add these aggregates together, you have, actually, let me go back. These little interspaces between the pores, these pores are micropores. When you add them together, you get macropores, which are big spaces where roots, are worms, arthropods, insects can live, and areas for drainage. Again, with compacted soil, there's not a lot of room for roots. There's not a lot of infiltration, so you get a lot of ponding, and there's just not a lot of life in the soil. The more biologically active your soil is, the healthier it's going to be, and the better it's going to be for your plants. And when it comes to soil health, it's all about biology. If you support the ecosystem's going to support you, and it's going to deal with most of the problems that you would otherwise run into. The more we mimic nature, the better our plants grow. That does not mean, however, that you're going to get no disease or no damage from insects or anything like that. But the damage that you do get will be minimal. And nature will balance, and it won't allow, for example, disease to wipe out your whole crop in most cases. So one of the things we can do is regularly amend our soil with organic matter. And if you're establishing a garden bed, then you want to put in about 200 pounds per 100 square feet of compost. And that equates roughly to five gallon buckets. Add compost whenever you till, generally about 50 to 100 pounds annually. This will help. When you till, you do damage. Adding compost when you till provides food for those microorganisms and insects and arthropods. And so in a sense, you've done damage. It's like a natural disaster. Adding that compost is like sending in aid after a natural disaster. It helps them rebuild quicker. If you think about a natural system, 2/3 of the organic matter that naturally is added to the soil comes from plant roots. So keeping living roots in the soil year round will help add to your the bank of your organic matter in your soil. You do have to be careful when adding raw, that is non-composted organic matter. When you add plant matter, sometimes you can get a temporary pull of nitrogen out of the system as the organisms process that. Usually it's about a week, sometimes 2 weeks. That's not as big a deal as adding raw manures because sometimes you get pathogens, sometimes you get smells, sometimes you get too much nitrogen and it will burn plants. So you have to be careful about adding raw organic matter. Understand that compost has nutrients, but it's not a fertilizer. We're not adding compost to feed the plants. We're adding compost to feed the soil organisms. They're going to feed the plants for us. We're adding compost for carbon, and that carbon is just like us eating carbs. You know, athletes will carb load before an event because they need that energy. Well, the carbon that we give through compost is energy for soil organisms. And the carbon cycle helps drive the nitrogen cycle, which pulls nitrogen from the air, pulls nitrogen from organic matter decaying in the soil, and that feeds our plants. In a healthy ecosystem, fertilizer is rarely needed because the soil organisms are doing it for us. Organic matter will also help retain moisture in the soil and will help make plants more drought resistant. With soils, we want to irrigate as needed to maintain moisture. think about the organisms in the soil. They need water too, not just your plants. But when you irrigate, you want to be consistent about it. Remember that fruiting vegetables need more water at flowering, fruit set, and seed set. Leafy greens are very drought sensitive and they need water consistently throughout the growing season. Heading vegetables need more water when they start to head. And root crops are most sensitive when the roots or tubers begin to enlarge. Too much water, on the other hand, can be a problem. It can cause things like blossom end rot. It can cause root rots. What we want to do is do infrequent deep watering, because frequent light watering reduces root growth. Basically, the roots will stay on top because they're getting water in the first layers of soil instead of growing deep and getting water from deep in the soil. And when they grow deep in times of drought, that water that's deep in the soil, that will sustain them. If all their roots are up at the top and can't get to that deep water, then they're going to have problems in the drought. Try and water at the base of the plant to reduce disease issues. We have a lot of disease organisms that live in the soil, and when that soil splashes up on the leaves, it can cause disease issue. You want to water early in the morning. That will help with retaining most of the water that you're actually applying, as opposed to running into issues like if you do it in the heat of the day, you could cause temperature shock depending on the difference in temperature of the water and the air. You could have some of that volatilizing off and not going into the ground. If you water late at night, you can be fostering disease as well. And you want to use mulch to help retain that soil moisture. Mulch can also add an extra layer of protection against soil-borne diseases. So depending on what type of gardening you're doing depends on how much you're watering and how you water. So containers and pots, they heat up much quicker than anything else, which means they're going to dry out quicker, which means they need to be watered more. Typically, heat of the summer, you're looking at least daily. With in-ground beds, particularly those that have high organic matter, you're looking at weekly, sometimes twice a week. And our raised beds are kind of in the middle because they can lose heat faster than in-ground beds, but not as fast as containers. Also, depending on whether you have if you have actual soil versus soilless media in the raised bed, depends on how quickly it'll drain and how much you have, or how often you have to water. We want to avoid walking in or on our garden beds. Once you have your garden bed established, you don't want to compact it. So you want to stay on paths or use a digging board. Over here in the right, we have an example of digging board. And if you stand on this, this disperses your weight out. So it doesn't do as much compaction. Because if we're going to work the soil and we're going to get the soil nice and fluffy and a good environment, we don't want to go back and then compact it. We want to minimize tillage because, again, we get nice soil and then we use tillage and we bust that soil structure up. We don't want to do that. Tillage can also cause compaction if it's done frequently enough. So we want to minimize tillage as much as possible using no-till techniques or minimal till techniques to avoid that compaction. We want to use crop rotation wherever possible. That will help with bringing a diverse set of microorganisms into the garden bed. It'll also help because it's going to be starving out disease organisms. It's going to help with interrupting the disease cycle. And typically, in most gardens, you're looking at a 4-year garden rotation. That's not always practical. I understand that. But ideally you want to do that. And you rotate by families. And typically the families that we rotate are nightshades, legumes, brassicas. These are the ones we worry about the most because they have the most disease pressure. We want to keep our gardens covered as much as possible, and we can do that with mulches. You can use natural materials like straw or wood. Plastics don't allow for water infiltration, so if you're using plastic mulch, then you have to figure out how am I going to water it to make sure that my plants get enough water. You can use succession planting, which means, okay, in the spring, I'm going to plant greens. And then later on in the spring, I'm going to go and I'm going to plant my tomatoes in that same spot. And then as my tomatoes mature, I'm going to plant something else in that spot. And then I'm going to do cover crops in the winter. And you're just keeping that garden covered the entire time. And you're building soil that entire time. And cover crops are what we plant when we're otherwise not using our garden beds. And cover crops technically can be anything. In agriculture, we usually break that up into legumes, grasses, and others. And if you need more information on cover crops, I'm happy to provide that. But a lot of times between our end of season in the fall and our start of season in the spring, if we leave the ground bare, we're opening it up to erosion. We're also wasting that time. In that time from late fall to early spring, the sun's still shining. All that energy is coming from the sun. We can waste it, or if we have living plants in it, they can utilize that, transfer that energy in the soil, and help build your soil. So cover crops are an important part of building your soil. And with that, I will take questions.
The only question that we had was on one of your early slides on what makes good soil, and it was asked, what does plant available water mean?
Okay, good question. So plant available water, let me see if can do this in slide. Okay, whoops. If I can get to the right. So when it rains, what happens is water ideally infiltrates into the soil, goes down in the soil. As it goes down and hits these aggregates, in the micropores, some of that water gets stored. And if the plants can access those micropores that have this stored water in it, that's plant available water. If it all runs down and infiltrates, that, or anything that infiltrates down past the root zone, that's non-available water. You've watered it, but it's gone beyond the root zone, which is another reason why we want deep roots, because we want that root zone to be as large as possible to allow for as much plant available water as possible. Hopefully that answered that question.
Also, there's a question, is there a difference between tilling and disking, and what is disking?
So disking is a type of tilling. Disking is where you have metal discs, and typically it's dragged behind a tractor, but there are some ATV disc setups. And disking is typically used to open up the top layer of the soil. Disking isn't really heavy tillage. It's fairly light tillage. Tillage can be plowing. It can be disking. It can be digging, really. Tillage is basically any type of earth disturbance for planting a crop. And sometimes, you can't avoid tillage. You can't grow potatoes in the ground unless you dig them. So, tillage is something we want to avoid as much as possible, but it's not always something that we can do. Sometimes we have to till. And light tillage sometimes is useful for weed control. I hope that answered the question.
That's all the questions that we have in the chat box.
Okay. Well, thank you all for coming. So future class offerings in 2 weeks, we have pruning. In February, we have propagation and annuals, perennials, and bulbs. And then in March, we go back to a weekly schedule, starting off with trees and shrubs, turf and weeds, container gardening, and pesticide safety for the home gardener. Also on February 1st, registration will open for our online vegetable class. This is a asynchronous online class about vegetable gardening. And the URL's here, and we'll be putting out more information on that on our website. And with that, I say thank you very much. If you have questions or comments, please let us know. If you get the survey, or excuse me, the class evaluation, please fill that out and help us to be responsible to the county and the state. And thank you all for coming, and we'll see you next time.
Thank you, Thomas.